Chapter 12, Solutions. I wish this was solutions to our personal problems, but alas, it is not. It has to do with homogeneous mixtures. Thirsty solutions. Why you shouldn't drink seawater. Seawater, of course, is salty and it tastes nasty, so why would you want to drink it? Well, if you were stuck at sea and you were desperately thirsty, you might be tempted to drink it. But as it passes through your body, it actually draws more water out of your body, causing you to be more dehydrated than if you hadn't drunk anything. And we'll look at that. We'll come back to that towards the end of the chapter. Seawater is a solution. When chemists say solution, they mean a homogeneous mixture of two or more substances. In seawater, water is the solvent. And sodium chloride is the primary solute, which is the minor component of this mixture. So most of the mixture is water. The terms solvent and solute, major component, minor component works most of the time to distinguish which is the solvent and which is the solute, but not always. So here's a picture of seawater and then an illustration. Here we have sodium and chloride ions dissolved in water. Nature has a tendency towards spontaneous mixing, unless that mixing is highly unfavorable energy-wise. So if we take a container that has pure water on one side and salt water on the other side, and we remove the barrier, I think we naturally understand from our life experiences that what's going to happen is eventually the water and the salt water are going to mix together and become uniform. This is a natural tendency that nature has. This also happens with drawers of clothing, right? They naturally tend to get all mixed up. So if you drink seawater, nature's tendency towards mixing causes a flow of the solvent to come out of your body into the seawater. So here we're looking at what's going on in your intestines. This is inside your body cells. There's a concentration of sodium chloride dissolved in water. And out here is the seawater passing through. The concentration of the sodium and chloride ions is higher in the seawater than it is within the cells of your body. Nature's tendency towards mixing causes the water molecules to move into this higher concentration solution, trying to equalize the concentrations of sodium chloride on both sides of these membranes. Cells are surrounded by semi-permeable membranes. These membranes allow small particles like water molecules to pass through, but they do not allow solutes like sodium and chloride to pass through. Any questions about that?